Hi, so my name is Tanya. I'm not really sure how necessary this is because I was able to cover everything in my original live demo during the Zoom. But just to be on the safe side, I've decided to just record this anyway. Um, so I wanted to share my project, which was Water Buddy. So essentially, WaterBuddy is a full stack analytics application for USGS groundwater data. So, just to show you what I have to start out with, this is the raw data from the USGS government website. For those who don't know, the USGS is an important government agency. They track a lot of our natural resource data. For this particular project, I wanted to focus on groundwater quality data. So I started with this raw data set. As you can see, it's quite long and messy, and it had a lot of inconsistent metadata rows as you go through this. So the first thing I had to do was create like a parser Python script. And this custom Python parser basically detects and strips the metadata lines. It validates the numeric types, and it also normalizes all this data into a nice clean CSV. Next, we can move on to the loader.py script. So for the database, I normalized the schema into two tables. One is a sites table, and one is a daily values table. The loader script basically reads the clean data and then performs the unpivot operation. And it turns wide column format into long column format SQL rows for the efficient querying. App.py is essentially the application, and we have index.html, a script.js, and a style.css document to support this. So with that being said, I think it's easier to just show you the application. So it runs as a web app. You can enter the system like this. So the cool thing about this is that you can randomly select different samples sites, and the IDs are populated here. You can hit send. And you can see here on the transaction log what is happening behind the scenes, just so you know that we are actually working with SQL. So we've loaded the site data. We can go to visualization mode and we can hit send. So what's cool is that you can actually see the time series data graphed here. And if you're wondering what these lines mean, each one represents a parameter. If you are a hydrologist, you would probably know that each parameter represents a different quality of the water, whether that's water level, whether that's a particular chemical that's in the water. Each of these codes represents something different. Additionally, we can go to stats mode. You hit send once again. You can look at a global summary of all of the data for that particular site, or you can look at some of the mean, median, mode type of data for each particular parameter of that site. And as you can see, we perform SQL joins, and we also do order by date time to ensure like that the plot we made earlier is in chronological order. And this does satisfy the data analytics requirement, and it queries the raw data and then uses the information to compute aggregations in memory, and it calculates mean, min, max, standard deviation. And these are like the stats cards. So essentially, the whole point of this application is for it to be nice and clean for someone in the field of hydrology to actually use this to look at data from the USGS in a nice, clean format. And so, in summary, this basically is the full ETL pipeline from the raw TSV parsing to the SQL normalization to the front end for data exploration. So, that is all for me. Thank you so much for your time.